This video will cover the Unit 10 review questions to help you study and prepare for Test 3. Our first problems we're going to work is surface area. We're going to round our answers to the nearest hundredths and be sure that we include appropriate units on our answers. So this first image is actually a cube, but it would also classify it in as a rectangular prism. So the surface area for a rectangular prism is going to be perimeter times our height. That's for our lateral area. Plus, we're going to have 2 times the base area, so our length times width. And recall that we need 2 because we have those 2 parallel sides that make it a prism. So let's first find the value for our perimeter. For perimeter, we're going to add up the sides. So we're looking at this square, or you call it a rectangle also. So we're going to add up the sides. So 3 plus 3 plus, remember it's 4 sides, so add up that many of those 3. Since they're all equal, we will want 4 of them, or you could even do 4 times 3, which gives us 12 for the perimeter. The height of this prism, remember it's going to go from rectangular shape to the other rectangular shape. So because we use this rectangle as our base, we want to use the value that connects that rectangle to the other side that's parallel. So the height of the prism is going to be 3, plugging in our perimeter and then our height for 3, plus we're going to do 2 times our length and width. So the values that you use for length and width, return back here to your perimeter. You used a length and width already to calculate your perimeter. Use those same values for your base area. So 3 and 3. So let's calculate this. 12 times 3 is 36. And then 2 times 3 times 3. So 3 times 3 I know is 9. And multiply that by 2 gives us 18. And then we can add those to give us the surface area of 54. Our units are yards, and because we are calculating surface area, it's in square yards. Let's take a look at our next problem. We have question number 6 is a cone. We're still working on surface area. So surface area of a cone, for that lateral area, we need 1/2 times the perimeter. However, perimeter of a circle is actually called circumference. So you'll do 2 pi r, and then we need our slant height. Then we're going to add that with just the base area because we only have one of these bases. We do not need 2 times, we just need the base area, so pi r squared. This is the formula that you could reduce the 1/2 and 2 and just use pi RL for your slant height there. So pi RL for this lateral area. I prefer having the 1/2, that way I don't forget it whenever I have to have it on other pyramids when finding the surface area. So I just leave it even with my cone. So let's start finding our values. We need our radius, and notice that value is not given. Because we don't know the value of our radius, we'll have to solve for that. I'm actually going to draw it in on this side so that I can see this right triangle that's being formed with the 2 values I have. This is a leg, so I'm going to let it be A, or really we could even just go ahead and use the variable R for our radius. We do have the other leg, which is 24, and the 25 would be our hypotenuse. So using Pythagorean theorem, we could solve for the radius. I'm going to go ahead and subtract the 24 squared. Being careful, 25 squared minus 24 squared would not be 1 squared. Either punch it in the calculator or be mindful of order of operations. You would do exponents first before subtracting. So 25 squared minus 24 squared actually gives us 49. To find the value of the radius, we'd need to take the square root. So when you take the square root of 49, you get 7. So that value there is 7 for the radius. So let's plug in our numbers. 1/2 2 pi, we just solved for 7 for our radius. The slant height for this cone is the height that goes down the slanted side, so that would be 25, plus we need pi r, we just solved for that 7, and then squared. Being very careful that each value you plug into the formula is the correct value that you need. The radius, we solve for that. That is this from the center of the circle to the edge. Slant height, it's the height that goes down the slanted side. And then, of course, the radius again there. So let's type it all in our calculator and be very careful. So we have 1/2 times 2 pi. Remember, the pi button is second, and then this caret key underneath clear, times 7. We're also going to multiply that by 25 plus pi with our 7 squared. That's a lot to type in, so always type it in again if you feel like you've messed something up. So rounded to, it said the nearest hundredth, so that'd be 2 decimal places. So here we see a 6 behind that, so it does make it round up. So our surface area is 703.72. We're in inches. Because we're finding surface area, it will be squared inches. Let's look at our next figure. Our surface area formula. Because it's a pyramid, we will need 1/2 the perimeter times slant height. And then we're going to add it with the base area, so length times width. The area of a rectangle would be just length times width. And we do not need the 2 in front of that because we only have one of those base figures. So for our surface area, we'll need to find our perimeter. So our perimeter is going to be 20 plus 20. And because it's 4-sided, we'll need that 4 times. 20 plus 20 plus 20 plus 20, or you can just do 20 times 4, so that'd be 80. We'll need our slant height, so that's given to us as that 32. And then we need our length and width. So length and width, again, I want to remind you that if you use a length and width in your perimeter, that is the same length and width you should use when you're calculating your base area for the surface area formula. So 20 times 20 for that length and width. So let's calculate all of that. So we have 1/2 times 80 times 32. We're going to add that with 20 times 20. So that gives us 1,680. We're in feet. Because we've calculated surface area, it will be squared feet. Let's now switch gears and look at our volume questions. We're going to find the volume for each figure, rounding our answers to the nearest hundredths, and again remembering our units for our answer. So this shape is triangular, so volume of a triangular is 1/2 base times height. It's triangular prism, so we're times height to make that 3-dimension. So let's first focus in on just the triangle shape. So here, for this triangle shape, I need to find my base and height. So we're going to look for a 90-degree angle to find those two values. So 1/2, my base, I'm going to let be 9, height be 15, because those two numbers meet at that 90-degree angle. Base and height must meet at that 90 degrees. Times height of the figure. We want to find the value that connects the triangle base figure to the other triangle base figure. That will give us the height of this prism. So the 12. So calculate that. So we want to take 1/2 times 9 times 15 times 12. We get 810. For our units, we have cubic. Volume is in cubic units, so cubic yards. Looking at our next problem, number 13, we have a cylinder. Even though it's leaned over, we still will follow the volume of a cylinder. So volume, we do pi r squared, because that's the base area, the area formula of a circle. It's pi r squared times our height to make it that 3-dimension. Notice here we need our radius, and the picture gives us a value that's our diameter. So to find our radius, we need to take that 12 and divide it by 2. So we have a radius that would be 6. Plug that into your formula, so 6 squared, and then multiply it with your height, so the 10. So let's go to the calculator. We got pi, so second pi, do your r squared times your height, rounded to, again, the nearest hundredth, so 2 decimal places. The 3 will not make it round up, so we'll leave it 1,130.97. It will not round up with that 3 behind there. So that volume for our units, we're in feet, so it will be cubic feet for our volume. Let's look at now our final volume question, number 15. This is a rectangular pyramid, so we're going to find the volume by taking 1/3, because it's a pyramid, it comes to that point. It's 1/3 times length times width, which is the area of that rectangle, times our height. So 1/3 length times width times height. So we'll start with our 1/3. Our length will be 7, width is 7, and the height of this pyramid, we need to go straight up the center of the pyramid to find our height, is 4. Notice we do not need this value given to us here that is 3. That is unnecessary. It is not going to be a length, a width, or a height. We do not need it. Do not think that you need to find the slant height either. When you're finding volume, remember you're filling up the inside of that figure. So think about, you need that inside height for the volume. Let's calculate that value. So 1/3, or 7 times 7 times 4. Round to the nearest hundredths, 2 decimal places. We'll leave it 0.33 when we round. 65.33. Our units are in yards, so it will be cubic yards. Number 18. We have Catherine using a cone to fill a cylinder with sand. If the radii and height are equal, meaning that they both have the same measure for the radius and the same measure for their heights on both objects, and Catherine fills the cone to the very top, how many cones will it take to fill the cylinder with sand? Well, because the formula for a cylinder, when you're talking about volume, we're filling it up, so we're talking about volume. That one is pi r squared times height is the volume of a cylinder. The volume of a cone is 1/3 pi r squared height. Because this volume is 1/3 the volume of the cylinder, it will take 3 of these to fill the cylinder. It will take 3 cones to fill the cylinder with sand. And it's all because of that fraction 1/3 that we use for those pyramids and cones. 1/3 of the volume of a cylinder. And it is important that the radius and height are equal, so that R value and that height value would be the same in both of those formulas. It would take 3 of those cones to fill the cylinder. Of course, it's also a good idea to practice the rest of Unit 10 review if you find that you need the extra practice.